Made up of a very large galaxy of stars like our own Milky Way, our friend in space is about 2.5 million light-years from the Milky Way. The way we study Andromeda has changed a lot since it was first found, from using telescopes on the ground to using space telescopes like the Hubble and the James Webb Space Telescope. We have come a long way. With each new piece of technology, we've reached new heights and learned more about the Andromeda galaxy. Given that we now know more about its makeup and structure, Andromeda has become a standard for studying how galaxies form and grow. This has given us more information about how the universe works in a bigger sense. Scientists think that we need to study the link between Andromeda and the Milky Way to learn more about the universe. This is especially important since the two galaxies will eventually crash into each other in about 4 billion years. Even though research and studies have moved forward, the James Webb Telescope recently got a signal from Andromeda that made scientists worried. Scientists all over the world are confused by this worrisome signal, which has led to questions about where it came from and what it might mean. The advanced sensors on the James Webb Telescope have found strange behavior right in the center of Andromeda. The signal sent back to scientists shows results that are very different from what has been seen before, which interests scientists all over the world. The signal shows that there are big things happening inside the galaxy, which might have something to do with its giant black hole or with things that haven't been seen before. One of the most recent discoveries is that Andromeda's mass might be much larger than the Milky Way's. This changes how we think about the sizes of both galaxies. The James Webb Telescope has also taken very clear pictures and spectra of Andromeda, which have shown how new stars are made and what chemicals they are made of. This new information is important for knowing how galaxies have changed over time and what conditions might be right for life. The telescope data also shows that Andromeda's active galactic center is becoming more active, which will affect its surroundings and determine how it will be structured in the future. Researchers are also learning more about how mysterious dark matter is spread out in the galaxy by studying the effects of gravity on stars in Andromeda. This should help us better understand how dark matter affects the physics of the universe. As it stands, one of the biggest mysteries in astronomy is dark matter and how it affects the world. Recent discoveries made by the James Webb Telescope have sparked many studies around the world as astronomers try to figure out what Andromeda is all about. We now know more about the past and future of the galaxy because new knowledge has come to light. So, what do different studies tell us about the Andromeda galaxy? There are some amazing things about Andromeda that set it apart from other galaxies in the universe. People are amazed by how big it is. New estimates put its width at about 220,000 light-years, which makes it one of the biggest galaxies in our group and even bigger than the Milky Way. Its mass comes from its huge size. It is made up of about 1 trillion stars, which is more than our galaxy. Scientists are also interested in how the galaxy is put together. Andromeda is not like most spiral galaxies because its center bulges, and its dense core is surrounded by rings of dust and gas. This makes it a great place for stars to keep forming. One of the most interesting things about it is its center, which has a double peak emission that suggests it has a supermassive black hole similar to but not the same as the Milky Way's. This gives us important information about these huge holes that eat matter and what they do. Andromeda is also surrounded by a sphere of stellar debris that is hundreds of thousands of light-years across and made up of stars, planets, and globular clusters. This space covers an interesting and thorough story about how the galaxy came to be in its past. The 460 globular clusters found in Andromeda also give us information about how stars form in their very early stages. This makes it easier to understand how star clusters form and how the galaxy first formed. Astronomers are getting closer to knowing what dark matter means in the big picture by putting together the puzzles of Andromeda. But there is still one question. How do they explain how mysterious it is and what part it plays in how galaxies move? Andromeda also has something else that makes it stand out: galaxies that orbit around it. It has more than 20 smaller galaxies making up its halo structure. Some of these galaxies are losing their stars and gas to the tides. Small galaxies that are nearby are pulled in and destroyed by the bigger galaxy. This shows that cosmic evolution is active and demonstrates how galaxies grow and interact with each other over time. How will things go from here for the Andromeda galaxy? Astronomers and people who want to learn more about the universe are both interested in its shape and the way it moves. Andromeda's growth is based on the idea that it could change from a spiral galaxy to a ring galaxy. There is evidence of a process that could lead to other rare pairings. This process could be caused by galaxies colliding or interacting closely with each other. If Andromeda is really moving in this way, it means that since it was born, it has had a lot of interactions with other galaxies. In the end, Andromeda's future rests on its impending collision with the Milky Way. Based on these models, the impact is thought to happen in about 4 billion years. After such an impact, these two very large celestial bodies will give birth to a new galaxy. Even though it may seem catastrophic, the impact is a normal part of how galaxies grow and change. Galaxy collisions don't have direct impacts though because the galaxies are so far apart. When the two galaxies collide, they will completely change forms and compositions as their gases and dust combine. New stars will be born, making for a spectacular show in the sky as the objects merge and shine brightly. Finally, this kind of cosmic event will result in the formation of a single irregular galaxy. The universe has a long history of collisions like this one, but the fact that we can directly observe and study it is what makes it interesting to us. The expected collision of the supermassive black holes at the centers of the two galaxies adds even more mystery to this cosmic show. It illustrates how complex and deep the evolution of the universe truly is. It is thought that the merger will cause blasts as matter is sucked into the black hole, releasing a significant amount of radiation. This process provides useful information about how galaxies change over time and how black holes influence this change. However, it raises an important question. What will happen to our solar system after this merger? The solar system would not be completely destroyed, but its direction and conditions could change significantly. This means that orbits might shift or even be ejected from the newly formed galaxy. To understand this process, scientists study similar large-scale cosmic events to predict how our galaxy might evolve in the long run. Because the space between galaxies is so vast, it is important to note that star collisions are very rare. However, changes in gravity could disrupt the fixed orbits of stars, potentially causing stars like our Sun to change their paths. Such changes could drastically affect Earth's climate, depending on whether it moves closer to or farther from the Sun. A colder climate could trigger a new ice age, while a warmer climate might lead to melting ice caps and rising sea levels. Additionally, the gravitational reshaping could alter the amount of radiation reaching Earth, adding to environmental challenges. The merging of the Andromeda and Milky Way systems highlights the intricate relationships between celestial bodies. Over time, the black holes at the centers of both galaxies may draw closer together, potentially making it easier for high-energy particles to reach Earth. This could lead to increased cosmic radiation, which might have adverse effects on Earth's ecosystems. Higher radiation levels could accelerate mutations in organisms and reduce biodiversity. The merging black holes could also alter Earth's orbit or axis, affecting global climates and ecosystems. While some species might adapt and thrive, others could face extinction. As clouds of gas from the nebula compress, new stars are likely to form. If this process occurs near our solar system, the radiation from these young stars could significantly impact Earth's environment, altering temperatures and ecosystems. These cosmic events shape the grand narrative of the universe's evolution. It is crucial to consider not only what has preceded these occurrences but also what may follow. Events billions of years from now might see humanity living elsewhere, possibly even outside our solar system. Exploring the Andromeda galaxy is key to understanding the Milky Way's history and future. The differences between Andromeda and the Milky Way refine models of galaxy behavior over time. Reassessing Andromeda's size and mass provides insights into the Milky Way's structure and challenges earlier perceptions of Andromeda's role in our galactic neighborhood. Recent findings suggest that the Milky Way and Andromeda are about the same size, contradicting previous ideas about their relative scales. This new understanding impacts theories about gravitational influences in the local group of galaxies. Currently, the Milky Way is a barred spiral galaxy, but its shape may change after interacting with Andromeda. Observing Andromeda's evolution aids in understanding major galactic transformations. Cosmologists use advanced technologies to model the anticipated collision, which will alter star formation rates, gas and dust distribution, and galactic cores. The history of telescope advancements, from early 1600s instruments to the Hubble Space Telescope, has significantly enhanced our understanding of the cosmos. Hubble, launched in 1990, provided unprecedented clarity, leading to discoveries about black holes, the universe's age, and its expansion. Complementary telescopes like the Chandra X-ray Observatory and Spitzer Space Telescope have expanded our knowledge by observing phenomena invisible to ground-based instruments. These tools revealed insights into star formation regions, supernova remnants, and the universe's microwave background radiation. Dark matter remains a persistent mystery, accounting for about 90% of a galaxy's mass yet remaining undetectable by traditional methods. Observations of Andromeda indicate that stars at its edges rotate at similar speeds to those near the center, defying earlier predictions. This suggests that dark matter influences the galaxy's structure and motion. Studies reveal that Andromeda's dark matter halo extends 1 million light-years from its center, significantly impacting the orbits of its satellite galaxies and overall dynamics. The distribution of dark matter in Andromeda shapes star formation, spiral arm development, and galactic collisions. When Andromeda and the Milky Way collide, their dark matter halos will also interact, influencing the structure of the resulting galaxy. Observations of Andromeda contribute to our understanding of galaxy formation and evolution during the universe's early stages. Detailed studies of Andromeda's structure illuminate processes like spiral arm formation and central bulge growth, refining cosmological models. Signals from Andromeda enhance the accuracy of the cosmic distance ladder and provide insights into the Hubble constant, crucial for measuring the universe's expansion rate. Examining Andromeda's stars and their chemical compositions reveals information about nucleosynthesis and chemical enrichment in the universe's infancy. Now we have a better understanding of how stars are born, die, and contribute to the chemical evolution of galaxies. These discoveries deepen our knowledge of the universe's past, present, and future,